Ready? Good day and welcome to my YouTube channel. I am Acho Francis Deban. Today, again, we're going to be handling the volumetric analysis formulas. We've done that before, but I think it's a little old, so we just need to change one or two things. And it is important that we continue to revise these things so that we'll be able to get the standardized update of whatever we're dealing with. So in the volumetric analysis, which cut across standardization, we have to calculate for our concentration of either the acid in mole per dm cube, the mass concentration in gdm cube, amount in mole, we have mass in gram, we have percentage of water of crystallization, and percentage purity, and so on and so forth. So in all of these, if we remember our formula very well, it helps us to go a long way in resolving the differences that exist between them. And we'll be able to know which formula appropriately to be applied in resolving a question or the other. There will be instances where one question may be taking or having more than two formulas or three formulas to be used. So if we're not conversant with the formulas, we find it difficult to go by it. So let us start, all right? We'll begin with the first one. So these are the volumetric analysis formulae. So let's start with concentration. In concentration, we have the molar con and the mass con. So let's start with molar concentration. Number one. So A, we have our CAVA. So this is the one we use, the first formula we're going to use in calculating our concentration, where the C is for concentration of the acid, while the CV is the concentration of the base. But let me give us what it means. It means we can also use it to calculate for the volume, or even the number of moles of acid. But majorly, we use it for the concentrations, where our CA CB Now, the CA is concentration of the acid in mole per dm cube. The unit is very important. You can't miss that. You can also have it as mole per dm cube. You see that you have it -3 or you put this, alright? So the same thing goes here, concentration of the base in mole per dm cube, volume of acid in cm cube or dm cube, volume of the base in cm cube or dm cube, number of moles of acid, number of moles of base. It is important that in the course of your calculations, you mustn't forget the unit. Without a unit, you will not know whether, or the instructor wouldn't know what you're calculating for, whether you're calculating for the acid, or whether you're calculating for the base, or you're calculating for mass concentration, or you're calculating for amount. So the unit tells you that this is for the molar concentration because it is mole per dm cube. If it is amount, it will be mole. So if you make mistake in the unit, you are likely going to fail because the instructor wouldn't know what to mark. So it is very important you take note of that. So this is A for molar concentration. Let's take the next one. B, molar conc in mole per dm cube mass conc in gdm cube relative molecular mass in gmol. So we have the second formula here. We know that molar conc is equal to mass concentration over relative molecular mass. So the units are very important. You always take them, put their unit. And if you check very well, mole per dm cube. Alright? So if I take out this, the gram out, this is mole per dm cube. If you inverse it, you have this. So let's take our third formula, C. Molar conc, amount in mole over volume in dm cube. So here, this divided by this is mole per dm cube, which is the unit for molar conc. You know that you're right. So this is our third question, our third formula for solving what? Molar concentrations. So let us look at mass concentration. Why? The instructor made questions like calculate the concentration of the acid. Now, there is no distinction as to what you are calculating until the unit is included. Concentration of the acid in mole per dm cube or concentration of the acid in gdm cube. So now this is concentration in mole per dm cube. That's why we call it molar concentration. So mass concentration, the unit is gdm cube. So I want to spell that one out so we'll know the difference. So 2, let's go for mass conc. A of mass conc mass conc in gdm cube equals to molar conc in mole per dm cube times molar mass. Molar mass in gmol. So, if you multiply these two, you now have the mole, we'll cancel out the mole. You have gdm cube, which is the unit for mass concentration. So, you see that mass conc is actually truly in gdm cube. So, let's take the next one on that. B, mass conc in GDM cube is equal to mass in gram over volume in dm cube. If you divide, we have GDN cube, which is the unit for mass concentration. So that is our second formula for mass concentration. Let's go to amount. The third one, amount. Amount in mole. So A, amount is equal to mass in gram over relative molecular mass in G mole. This cancels this. You inverse it, you have your mole for amount. B, amount in mole is equals to molar conc in mole per dm cube times volume in dm cube. This will cancel this. You will left with mole. So amount unit is in mole. So that's our third question. In questions like this, you can be required to calculate the mass. You should know that mass here, for example, is amount times relative molecular mass. So if there is a need, you should know how to change your subject or formula to get what you want. And even here, just you have amount is this, you can be required to calculate the volume based on the parameters that will be given. You know that volume is equal to amount over molar concentration. You get your volume from here, change your subject. So let's move down to percentage of water of crystallization, the fourth one. Percentage of water of crystallization. We have the relative molecular mass of hydrated salt or hydrated acid or hydrated whatever substance it is over the mass conc of the hydrated substance is equals to relative molecular mass of the anhydrous substance over mass conc of the anhydrous. When we start solving questions, although we solve a lot of them in our channel, which you can go back to check them out to see. If you go to percentage of water of crystallization in this my channel, you're going to see questions which we've used these formulas to solve. More than 3 questions if not mistaken. You see how they have been applied. Although we're going to solve some as time goes on, but it is better you go there to refer to understand how the principles work. Alright, so now we have our fourth, which is percentage of water of crystallization. So let's look at percentage purity. Percentage purity is mass conc of pure sample over mass conc of impure sample times 100. B, we have percentage purity plus percentage impurity is equal to 100. So when you've gotten your percentage purity, you put it here. You can easily get a percentage impurity by making this the subject of formula. You take this across, 100 minus whatever is the percentage purity gives you the percentage impurity. Well, with these few formulas, we'll be able to resolve a lot of things that has to do with volumetric analysis in terms of calculations. And it is important we have them all in our hands, as we should know the formulas and when to apply. When a question is given, you list out the given and also list out what is required. So by that, or by so doing, you will know exactly what is required of you. And with the formulas handy, you'll be able to switch ways, whatever the situation is, when you want to solve any question that you are required to do. So thank you and have a nice day.